Hi guys, I'm Shohit Padhe. In this video, I'll be sharing with you my solution of Amazon Machine Learning Challenge. I have used deep learning to solve this problem and the model was able to achieve around 77.67% of accuracy. Okay, so let's move to the problem statement. We got the data of customer reviews and our task is to create a machine learning model to analyze the feedback and identify the key aspects of the given reviews. The objective of this model is to provide the insights to retailers and e-commerce platforms about improvements that are required for a better customer satisfaction. Training data contains around 5,960 rows and 3 columns, and testing data contains around 2,553 rows and 2 columns. The data contains features like review text, review title, that represents the full and short description of the reviews, and our task is to predict the topic. The topic denotes the key areas where the improvement is required to make the customer happy. Evaluation metrics for this problem is top and accuracy. Now the question comes is how to calculate it. We calculate top and accuracy by checking if the correct class is present in the top n predicted classes. Let's understand this from the given example. Suppose if we want to calculate the top 3 accuracy where n is 3, then the top 3 accuracy for the given example is 100%. Because all of the correct class is present in the top 3 predicted classes here. Let's change the n from 3 to 1 and this time we want to calculate the top 1 accuracy. That is 40% because only 2 times the correct class is present in the top 1 predicted class out of the 5 records. So now we have a good understanding of the problem statement and the evaluation metrics for this task. Let's explore the data. So let's begin with by observing the first few rows of the data. So one thing you will notice here is we have duplicate data in review text and review title. For example, in the first and the second row, review text and title are exact same, but the topic is different. So the question comes is how to handle this situation. If we feed the exact data to ML model, the model will get confused because it will find hard to learn the mapping between the input and the output. Why? Because the same input data has multiple outputs. Test data also contains duplicate data in the review text and the title. Another question comes here is, do we need to predict the same topic for the duplicate rows or different one? We'll park these questions for a time being. We'll move ahead in our analysis and check does the data contains any missing values or not. As we can see here, data does not contain any missing values. We don't need to handle this situation. Let's create some new features. I am creating a new feature info by concatenating review text and review title. I am also creating features like review length, review word count, review title length, and review title word count. Let's draw a few plots and get a better understanding of the data. This is the frequency distribution of the target topic. We can clearly see that around 1194 times customer wrote a review about the bad taste and flavor of the product and around 390 times about the shipment and delivery services. This plot tells about the average length of the review text per topic wise. For example, whenever a customer complains about the ingredients of a product, the average length of the review is going to be around 431 characters long. And for a topic shipment and delivery, the average length of the review text is 181 characters. Likewise, this plot tells about the average length of the review title per topic wise. For example, topics like false advertisement and how to teach you has an average review title length of 31 and 20 characters long. Let's analyze the average word count plots. This plot represents the average word count of review text per topic. According to this plot, whenever a customer gives a review about the ingredients of the product, they are going to use around 77 words as an average. Likewise, this plot tells about the average word count of review title per topic. According to this plot, review title for ingredients topic contains as an average 5 words and 4 words for every other topic. Interesting, isn't it? Let's explore about what are the important words whenever a customer writes a review about a specific topic. This represents the important words present in the review text and review title for bad taste or flavor topic. From the words like taste, flavor, horrible, awful, gross, terrible, we can easily understand that a customer is very unhappy about the taste or flavor of the product. Likewise, these are the word cloud of review text and review title for the packaging and the expiry topic. Here the important words are damaged, broken product, opened, expired, received are very much related with these topics. Now coming back to the earlier problem of how to deal with duplicate data. As we know, a dataset contains duplicate rows. For example, a same review text and review title contains different topics. To handle this, we'll transform the data from classification problem to multi-level classification problem. To begin the transformation, we group the training data by review text and review title and create a list of topics that falls under group. Then we'll use the multi-level banneralizer to generate the multi-level target columns. These columns contains the values 0 or 1. If a review falls under a specific topic, then it contains 1, otherwise 0. Now our target column is ready. Next thing to work on is feature extraction from the customer reviews. Let's start with the text pre-processing. I am using a smart way of finding the necessary pre-processing steps by analyzing the embedding coverage. So what is embedding coverage? Embedding coverage is the percentage of finding the words of corpus in pre-trained embedding vocabulary. Higher the coverage, more the advantage we are going to get by using pre-trained embedding in the deep neural networks. Let's understand better with an example. Suppose this is the vocabulary of pre-trained embeddings, and for the demonstration purpose, our review corpus is this. Let's create a vocabulary of review corpus. Words in green are present in pre-trained embeddings, and words in red don't present in the embeddings. So the embedding coverage is 45% because out of 11 words, 5 words present in pre-trained vocabulary. Now you have the idea of embedding coverage. Let's start the process. We'll first load the pre-trained globe embedding files. This file contains around 2 million words. Going further, we'll analyze the coverage of info feature. This feature we have created by concatenating review text and review title. We can see that we have found embeddings for 55.82% of vocabulary. The top words that are not found in the globe embeddings is the BR tag. No doubt, this is one of the HTML tag. Let's remove all of the HTML tag from the info feature and check the coverage again. This is the pre-processing function we have written. So this will remove all of the HTML tags. As a result, we can see here our embedding improves from 55 to 57%. Now have a look at the top words not found in the global embeddings. These words are like don't, can't, it's. So how to handle these words? We'll use TreeBank word tokenizer. TreeBank word tokenizer treats most punctuation characters as separate tokens. So this tokenizer splits standard contraction, example didn't to did and anti. Let's also add this tokenization into pre-processing function and explore the embedding coverage. As you can see, after applying our new pre-processing function, the coverage improves from 57 to 79%. Can we do anything else to improve further? The answer is yes. Look at the top words not found in the embedding vocabulary. They all contain a dot as a last character. So let's replace the dot with the space in the pre-processing and check the coverage again. Wow! This small enhancement in pre-processing function improves the embedding coverage from 79 to 91%. Is there anything left in pre-processing? Answer is yes again. We can see from the top words not found in the vocabulary, they contain a symbol like addition, subtraction, division. Let's remove those and check the coverage again. So we have written a function here that takes care of all these symbols. So as you can see here, we got further improvements from 91 to 95. What next now? Still, I can see a few symbols. How to handle these? Let's list down all the symbols handled by globe embeddings. Review character represents all the symbols review contains except English character and numerical symbols. Symbols to delete represents all the symbols not present in the globe embeddings. We'll delete all of the symbols from the review if that present in the symbols to delete. Let's do the pre-processing and check the coverage again. I can see a huge improvement from 91 to 95 of the embedding coverage. I am creating the Xtrain and Xtext by applying the final pre-processing on in feature. I am also using Keras tokenizer and convert the text tokens into sequences. Let's analyze the length of sequences. We have sequence of various lengths and we need to convert into the same length. We can see on an average length of the sequence is 52 and 75% of the sequence lengths fall under 68. As a safe side, we can fix the max length of sequence to 100 for converting all of the sequence into the same length. We are using the PET sequence to achieve this. Another trick I have used in this competition is I am creating an embedding matrix by concatenating three embedding matrices generated from three different pre-trained embedding files. This is the graphical representation. I want to take the advantage of different pre-trained embeddings, so I have assembled them together by concatenating it. Let's have a look at the model architecture. The first layer is the input layer. The output of input layer feeds into embedding layer. Next, I added two layers, bidirectional GRU and Con1D. Feed from Con1D goes into two parallel layers. Those are global average pooling and global max pooling. Then we concatenate the output of average pooling and max pooling and feeds into the final dense layer. I am also using early stopping and model checkpoint callbacks while training the model. We initiate a training here. We can observe the model performance by model accuracy plot and the model loss plot. So our model accuracy plot looks like this and the model loss plot looks like this. Now our trained model is ready to make the prediction. Only thing left is how to predict the topics for duplicate reviews. First, we do the prediction on test data after removing the duplicate reviews. At the time of generating the submission file, we use the following strategy. If the review occurs n times, then submit the most n correlated topics. We'll understand this with the help of example. Suppose this is the test data First, we remove the duplicate rows. Then we do the prediction and the probabilities of the predicted topics looks like this. Then we sort the topics in descending order of their probabilities. As we know, in the original data, same review occurs twice. So we have selected the top two topics for this reviews. So this is how we'll take care of the duplicate data in the test file. Thank you guys. This is all I have for this video. Please do share your thoughts about this video in the comment section and do not forget to subscribe the channel. Thank you. Bye bye.